My name's Corey Linkle. I'm the Associate Director of the undergrad program here in Biomedical Engineering. And with us today, I have Chantal Brown, our academic advisor, who will help me present when we get to the curriculum part of things. And I have several BME student ambassadors. So why don't we just have Chantal, you lead, and everyone just introduce yourselves for a moment.
I'm Chantal Brown, I'm the academic advisor.
And then Charlie, do you want to go first?
Well, I'm Charlie Martin. I'm a senior in biomedical engineering and will be going into the 5th year master's program. In that, I'm going to be focusing on neural engineering work in the Darlet lab.
All right. Zach?
Yeah, hey everyone, my name is Zach. I'm a sophomore in biomedical engineering, and I plan to get my master's and move to industry eventually.
Excellent. Olivia?
Hi everyone, my name is Olivia. I'm also a sophomore currently. I haven't really decided on a specialty yet, but I'm considering biomechanics and biomaterials, and I'm also looking into a secondary nursing degree.
Shahryar?
Hello, I'm Shahryar Khan. I'm a current senior, and what I research mainly is more on the molecular biology side of things and protein engineering.
Cool. Kevin?
Hi everyone, I'm Kevin. I'm a sophomore, currently also minoring in ECE. I'm currently also doing research and focusing on instrumentation, and also plan to go to grad school.
Juliana?
Hello, I'm Juliana Kirsten. I plan to graduate in December of 2021, and I have a focus in clinical engineering and hope to go into industry.
And Parker?
Hello, I'm a senior in biomedical engineering. I'm also in the pre-med track. I focus on biomaterials for regenerative medicine.
All right, thank you guys. And they will be helping us present throughout this presentation and be available for questions afterwards. So let's start by getting on the same page about what biomedical engineering is. It's a very interdisciplinary discipline within engineering, and it's where all of the engineering disciplines meet to solve problems dealing with living systems, healthcare, and the human body. And we have 4 areas that our faculty really specialize in their research. And that reflects into our coursework and upper level classes that you can take as well. So I'm going to start by having, yes, Chantal?
I just want to let everybody know that if you have questions while this is going on, you can type those in the chat. If you don't feel comfortable having the questions be available for everybody, you can send them to me privately.
Perfect. Thank you. Yes, please feel free to ask questions throughout the presentation. We will address them mostly during the question and answer at the end, but if there's any that are really relevant to what we're presenting at the moment, we might address them right then as well. All right, so the different areas of excellence within our School of Biomedical Engineering, I'm going to ask my student ambassadors to pick one, and Parker gets to go first because he got last. He was last to introduce himself, so he gets to pick one and say what area of engineering is closely related to it, and give us an example of what it is.
So I'll go with engineering, biomaterials, and biomechanics because this is the closest to what I have. As you can see on screen, there's a picture of the submucosa. And so basically what's done here is they artificially create an organ either through natural or artificial means to replace a piece of the body. So for here, we have to make sure that the mechanics act how they are supposed to, since you are replacing a function of the body. And we have to make sure that it is accepted by the body.
All right. So very much mechanical and materials engineering related. Thank you. Kevin, do you want to do one similar to your research?
Yeah, sure. Okay, so the closest thing to my research is actually instrumentation. The lab I'm working on focuses on primarily diagnostic devices, and currently I'm working on an incubator, a portable incubator for prenatal infants. So that's pretty cool. So what you basically see there is a prosthetic or also implants. So a lot of the instrumentation that you get to work on in BME is either external or internal, depending on which lab or you want to focus on. So there's a lot of variety there too.
Yeah. And so that's building circuits that model or measure or interface with the nervous system for the most part. So with that prosthetic hand, they're looking at the control systems connected to the nervous system. Yeah, so very much electrical engineering related. Who wants to go next? Shahryar, you want to?
Yeah, so I could take the systems and quantitative cellular engineering aspect. That mostly focuses on, it has a lot of like logistical basis and a lot of there's a lot of code involved in that one and more of the computational side for the systems engineering. I know in the lab that I'm currently in, there's a computational side that works with the entire system of or like a subset of the system of neurophysiology and works with the different proteins. So that's what you could expect on that side.
Mm-hmm. Yeah, so this is probably more of the catch-all one. So it's harder to explain because it has systems engineering. We'll have more biological and chemical engineering applications at times when you're doing more looking at biomolecular interventions or cellular therapies. Genetic engineering would fall under this, but also on the computer science side, looking more at big data and quantitative approaches to solving the human body, problems with the human body as well. And so, yeah, it has quite a lot of things crammed into that one title. And then Juliana, can you explain imaging for us?
Yeah, so imaging mainly focuses around ultrasounds or CT, MRI machines that help diagnose and characterize different disease states that can be used in the clinical setting.
Perfect. Yeah, and also very electrical engineering heavy. Signals and systems is vitally important for this. Also very physics heavy. Okay, moving forward, let's talk a little bit about what makes the biomedical engineering program unique at Purdue. So what distinguishes it from the other engineering disciplines? And so one thing is we're very hands-on. We have labs every semester through senior design. We're a smaller program, so you have exposure to faculty. It's very likely that you will get to know your faculty quite personally and feel more like you're friends and colleagues with them than looking up to someone who is unreachable. And the program is small and diverse. Our student ambassadors are a good example of just the wide range of interests and personalities and backgrounds that come into this field. And we really brag about this sort of family feel that we're trying to, this culture of collaboration and family feel that we're trying to maintain in our program. It's been tough with COVID, but I think we're still doing a pretty good job. I hope so. But can some of you let us know, some of you ambassadors, let the students know why you chose BME specifically? And we'll start with Olivia.
Yeah, so I chose BME because for the longest time I knew that I wanted to do something related to medicine. And I really liked that the program was small. I came from a small high school. I had about 100 people in my class. So while I like being able to be on campus and have, the 40,000 students, however many it is, and being able to make the campus feel big, the BME program itself is small enough to where I recognize at least one face, plenty more every single time I walk into the building. And it's been really great, especially since classes have resumed in person partially, to start getting to know my classmates and faculty members. And the other cool thing too that I really like about the program is a lot of our classes right now coordinate with the labs. So Dr. Linus, who teaches our biomechanics course, oftentimes will step into our lab and, you know, check in on how we're doing, offer us advice. So it's really cool to be able to talk to professors almost all the time whenever we're in the building too.
Yeah. Zach, can you add to this? Why you chose BME?
Yeah, absolutely. Yeah. So I actually came from a bigger school. So I originally, when I was looking for colleges, I was like, okay, I'm going to have to pick like a small college. I want like that one-on-one interaction and everything. And then I looked at Purdue just, you know, on the off chance that, okay, maybe they had something for me. And I looked more into the BME program, and they were outlining all these unique aspects of the program that Corey just talked about. And I kind of took a chance. I was thinking, okay, maybe they really will have like a lot of instructor or faculty to student exposure, and it's absolutely the case. I can't think of a single class where I haven't, you know, been able to go up and talk to the instructor one-on-one, ask them a question, talk to them about an idea I had or something like that. So all of your interactions with the faculty are going to be very personal, very one-on-one. Despite how big Purdue is, the BME program is small enough that you can really find a home and find a place in any classroom and really any setting. And just like how Olivia talked about, even as a sophomore and in COVID, I can walk through the BME building and see like a couple people that I know just passing by. So it's really nice. It feels really comfortable being able to learn like all of this challenging material with familiar faces, and just having people to rely on in case things, you know, get especially tough.
Excellent. And Charlie, can you give us a senior's perspective?
Yes, I can. So when I initially was looking at BME, I decided I wanted to go into it because I wanted to do prosthetics development. That changed quite a lot. I'm now looking more at neural engineering and possibly some cardiovascular. But what really sold me on BME once I got into the program was that I didn't realize how expansive BME is in general. Like, yeah, you go into it, you might know what you want to do, but when I went into it, I was like, I want to do prosthetics. Now I'm like, oh, I can do cardiovascular, I can do neural engineering, I can do, you know, I could even go off and do, I know a person who's going off to do medical device sales. And it really has opened my eyes to what I can do with this degree that I didn't expect I could do, because there are so many different opportunities in BME that you can develop off of for what you want to do, instead of just being pushed down one straight path.
Yeah, that's very true. We do have such a wide range of options for career choices, and I'm going to talk about that in just a little bit. We really, in preparation for the possible career choices that our students go into, we really work to give our students lots of opportunities to taste before they buy, kind of. So they get a chance to, if they're not sure if they want to go into industry, we have lots of co-ops and internship opportunities. If they're not sure if they want to go to grad school, it's so easy to get research experience in BME. So many of our students get involved in research because all of our faculty are really supportive of mentoring undergrads in research. We have project experience, global leadership opportunities, study abroad opportunities. And if you're not sure if you want to go to med school, we do have several clinical exposure opportunities. One is coming up in Maymester for our sophomores. And so it's a pretty exciting opportunity there. So very quickly, Juliana, what have you done outside of the classroom to prepare you for your future?
I have participated in 2 internships and a 4 rotation co-op experience, so a lot of industry experience. I hope to graduate in December of 2021, which will put me at 4.5 years, as the last line of that current slide states. And through those experiences, I've been able to connect what I learn in the classroom and apply that to the real world and see how even the minute, thing that you might be learning in the class, there is opportunities to apply it into industry.
And Parker, what have you done to prepare yourself?
So I've
For
done a
where you're
few
going
things on this list. So I've done research for credit for over 2 years now. When I first got into my lab, at the same exact time, I was learning to culture cells as part of one of the labs that first labs as part of BME. And so from there, I've expanded quite a lot on what I'm able to do. I've gone into areas of animal handling, so coming up with animal studies, to using a multi-million-dollar laser microscope. So I've definitely advanced much farther than when I first got in here. I've done a study abroad in Germany that was not part of the BME program, but I've gone study abroad, and I've done the IU Methodist Hospital collaboration, where I got to see more hands-on the clinical setting.
Awesome. Now, and I'm just going to let everyone know, I could go through each one of our student ambassadors and they can list off all the things they're doing because they're all very involved. But I'm going to keep moving forward for the sake of time. So when I speak of co-ops and internships, I want to be clear that we have a lot of co-op and internship opportunities within Indiana itself and within the larger Midwest region. Healthcare and healthcare products are the #2 export of Indiana, and many people don't realize that. So every one of the companies listed here in gold, in these gold boxes, are actually companies that we have a reciprocal relationship with, meaning they are guaranteeing that they're taking our students every year for co-ops and internships. But we have students get co-ops and internships at companies around the world and around the country. Some international ones, a lot all over the entire country. One of the cool ones I want to point out is at Apple, where our students have gone on to work on the biosensors on the back of the Apple Watch, and actually we're responsible for validating the EKG function that came out a few years ago. I mentioned we have study abroad programs. We have both long-term study abroad options for your junior and senior year that match the semesters that we have that you would be taking abroad, match the semester that you would take here. So you're not setting yourself behind in any way to do a full semester abroad. And they are taught in English, but we also have a whole bunch of short-term study abroad opportunities. The Global Device Design in Ireland is probably one of the most long-running ones we've got, but we have several in Scandinavia, Ecuador. We've got a few that pop up. There's one that's been going on in Vietnam. So lots of cool opportunities to do study abroad, long and short term. We also want to talk about, so all of this is to help our students get prepared for where they're going after graduation, because we do like to have our students kind of begin with the end in mind and try to work on experiences that are going to help them to where they're going to go. And this is my pre-COVID data, because obviously COVID-19 threw everything, threw a wrench into everything. But as you can see, half of our students on average tend to go into industry. About a third to a quarter of our students go on to grad school every year. So this, the 8% and the 25% in sort of the gold colors. We do have a very popular 5th year combined bachelor's master's program that Charlie was talking about doing. And that's a very popular way, and you can do it with the thesis, so research-based, or a professional-based one without a thesis that's just coursework. And then about 6 to 10% of our students every year go on to medical school. and like Parker's going to do. And so that's very important that we do have students that are successful getting into all of these programs around the country. In terms of industry, like Charlie said, you're not stuck with just medical devices. You could work in the auto industry at Ford, Fiat Chrysler, or GM in their crash test dummy or ergonomics divisions. They hire BMEs. Obviously, companies like Apple, Fitbit, companies that make wearable devices with biosensors in them, hire biomedical engineers, and companies that make normal consumable products like Kimberly-Clark and Procter & Gamble, everyday products that intimately contact the human body, whether it's hair care, skin care, diapers, facial wipes, feminine hygiene products, anything that intimately contacts the body. These companies have begun hiring biomedical engineers to work with their teams of engineers to design these products. So we've broken out of just the medical device field. We also have the pharmaceutical industry as well that we send a lot of students in. And Juliana did her co-op at a pharmaceutical company, so she can talk about that more in the Q&A. And then quickly, here are some of the grad schools and medical schools that our students have gotten into in the past, including IU School of Medicine's MD PhD program that we sponsor here on this campus, because we do have a branch campus of IU School of Medicine on the Purdue campus now. And then I'm going to now transition over to Chantal to talk about the curriculum.
Okay, so within the BME curriculum, the first 3 semesters that you're in the program, we try to introduce you to the breadth of the field. And then for the last 3 semesters, with all of the electives, that's where you have the opportunity to really focus on the area that you're interested in. And I'll be calling on my ambassadors to talk mostly about the labs, because every semester we do have a lab course that students are required to take. And so you are doing hands-on activities, doing more of that practical knowledge side of things every single semester that you're in the program. So as you can see on the screen, fall and spring of sophomore years, the credit hours are fairly high. The reason for that is because during sophomore year, you also, in addition to getting your biomolecules, biomechanics, biomaterials introductions, you're also getting a lot of that basic coursework out of the way. So your Calc 3, linear and Diff-EQ for math, your physics, your statics, your basic programming course, thermo. If for some reason during first year engineering, you decide to do biology or CS 159 as your science selective, you would obviously not take CS 159 in the fall. You would instead take Chem 116. If you decide to do something like biology for your science selective, you're looking at a minimum required credits of 22 during that fall semester. So it is a heavy semester credit hour load in the fall and the spring sophomore year. But would one of my sophomore ambassadors like to talk about the fall semester lab?
Yeah, sure, I can talk about that. Yeah, so the fall semester lab is in coordination with the biomolecules class, which is 201. So that lab focuses a lot on the kind of biological side or biological or chemical side of biomedical engineering, you could say. So for example, the first experiment that we did in that lab was, I believe, isolating a plasmid from bacteria. So it's a lot of that type of work. It's a lot of pipetting. If you're familiar with like micropipettes, you do a lot of pipetting. You do a lot of fluorescence readings, a lot of that type of stuff. on like 96 well plates. So you're going to develop a lot of skills in more of the biological, the microbiological assays that you're going to need in later labs as well.
And all of those skills that you learn in the 205 lab, they make you competitive for co-ops after that fall semester. So we do get a number of sophomore students who go on and interview for co-ops to start spring of their sophomore year and are able to get, some of them get multiple offers. So we do, like, the skills that you learn are useful and will help you even outside of that, early on, outside of BME. And then Kevin or Olivia, have you guys started the lab for this semester yet?
Yeah, I can talk about this lab. So in contrast to the 205 lab, 206 focuses more heavily on the mechanical side. So part of that is mechanical testing, tension testing, compression testing, learning what types of coupons are used in order to carry out that testing on different materials. So like a dog bone shape, and we learn how to design those in CAD as well. So we use Fusion 360 for that. And then it's also all throughout that lab, you're working with your lab group to design a solution to some sort of medical problem. So my group is currently designing a bone plate to address malunions that occur after a bone is fractured. So part of that too, we've designed mechanical testing techniques, viscoelastic testing techniques. So again, it just focuses very heavily on the mechanical side. We do stress strain curves almost every single lab, determining the ultimate tensile and compressive stress and fracture strength and all that kind of stuff.
Excellent. And then Corey, do you want to switch to junior year? So junior and senior year, junior year is very electrical heavy. You have your bioelectricity, bioinstrumentation labs, lecture and lab, and then your lecture for your biotransport. And then in the spring of junior year, you take your biotransport and then your junior, I call it junior design, BME 390. It is the prep course for senior design in the fall. And then also within junior year, you'll notice that there's less explicit courses that you have to take and more electives showing up. And then obviously senior year, the only explicit course you have to take is senior design, and then the rest of them are electives. So that spring semester, senior year, that 8th semester, for students who are ahead in coursework or who go on co-op, they have the opportunity, because that last semester is just full of electives, you can either graduate a semester early, or for students who go off on do that year-long co-op, they can graduate in 4.5 years instead of 5, and that includes that year-long co-op. So as you get further in the program, there's a little bit more flexibility. And then my current juniors, do you guys want to talk about the 305 lab and then the 306 lab? Or do I just have seniors here left?
I can talk about the junior labs. So BME 305, the bioinstrumentation lab, that is a circuits lab primarily, and you design a circuit for recording an ECG signal that measures the electrical signals within the heart. And then BME 306 is the biotransport lab, and this lab, you are primarily given an overarching problem, and then your team goes and finds a way to solve that. And so it allows you to take all the skills you've learned in your sophomore year and that fall of your junior year about how to run experiments and how to write protocols, and you apply that to a main problem given by your instructor. And then the junior design, or the BME professional seminar, that's a precursor to your senior design, and that allows you to find a lot of clinical problems that exist in the healthcare industry, and you're trying to develop a good problem to solve. So you're not necessarily building that prototype yet, but you're gaining the understanding of how to find that good problem that needs to be addressed.
And those students who did do senior design last fall, if you can talk about your project, give us a brief description of what your project was, or especially if you're going on and it's moving forward.
I can talk about mine. It's not
I think
necessarily
I can
moving
talk. I think Chantal kind of
forward.
broke up a bit.
You can go ahead, Charlie.
Charlie, are you still there?
Yeah, I think Charlie's frozen. So Shahryar, can you?
Okay.
Report.
Yeah, I can talk about my senior design project. So what I ended up doing was a little bit more on the biological side of things. We were addressing a problem that was addressed from the Department of Health of Indiana related to COVID-19. They wanted us to create an assay that would help, that would diagnose and change colors when it came in contact with a sample that was taken, like a nasal swab or they were still doing oral swabs at the time, but mostly nasal swabs. So with the assay, it would be, it would get the sample and it would change colors to detect if it was properly done or not, and it would focus on nanoparticles and proteins, and we had to identify the protein that we wanted to target and how it was all going to be done. So it was basically a problem from scratch, but we had a good advisor and it ended up going pretty well.
I think it dropped out, but I can also talk about my experience with senior design. Everybody can hear me, correct? Okay, good. Just making sure. Yeah, so with senior design, what my project and what my team worked on was actually a continuation of junior design. So we started with our design work, originally in junior design, finding that problem like Juliana said, and then we brought that into senior design, and this time in a different team, to continue and actually prototype development. So what we did is we looked at secondary effects of tourniquet induced ischemia. So essentially, when you put on a tourniquet, you're going to cut off the blood flow, which is what you want, because you want to save the person's limb. But that can also then kill cells within the arm. So we looked at essentially a cooling sleeve to slow down that ischemia that would develop from the use of a tourniquet.
So the senior design, two very different projects. We've had other projects. We've had students, teams collaborate with the Indy Zoo to help with animal care. We've had students help with nursing in terms of helping out expecting mothers. We had a team this year that focused on helping individuals who were wheelchair bound. So if you could think of something that would possibly impact and better the quality of life of living individuals, either animal or human, you could probably do that as a senior design project. Yes.
And our senior design projects, the teams get to either choose from an existing list of real world problems that have not been solved, or they can come up with their own project as well. And it just needs to be approved by the senior design faculty. So yeah, there's a lot of really cool projects that come through senior design.
And then you'll notice that there's a lot of electives. And so, like I said, that allows students, if they are heading courses, to get to possibly graduate early, or if you're on co-op for a year, you could also possibly graduate in 4.5 years instead of 5, including your co-op. but it also allows you to fit in extra academic curriculum, such as minors, certificates, pre-med requirements. You're able to specialize in particular areas. It may not be a full-blown declared minor, but let's say you're interested in ECE, but you don't actually want to do the minor. You could take ECE technical electives and sort of specialize in that electrical side of things while still doing a BME degree. Next slide. So, question we always get, how do you get into BME? The general across the board for all engineering disciplines, to get out of first year engineering, you have to pass all of your FYE classes with a C- or higher and have a cumulative GPA of 2.0 or higher. If you took courses at Purdue during spring 2020 and if you took those as pass, no pass, you can apply those to both your FYE curriculum and your BME degree requirements. And that is the same no matter what degree program you choose. So if you're between us and mechanical engineering and you took courses in spring 2020, you can also use courses that you took that semester as pass, no pass towards ME degree requirements. And then obviously you want to select the appropriate professional engineering school as your first choice. BME recommends that you take Chem 116 as your science selective. We do recognize that if you did not take Chem 115 first, then it's going to be tough to take Chem 116 because 115 is a prereq. If that's the case, then we recommend that you take CS 159. And that's just so that you can lighten your course load in the fall, because if you don't take one of those two, you are looking at a required course credit hour load of 22 credit hours in the fall. Next slide. So our transition to major, we will admit most students in May. We do follow the 3232 guarantee. If you want more information about that, please see your FYE advisor or Google the Purdue FYE enrollment management policy as it states on the screen. This 3232 guarantee is only active in May. And there's a lot of fine print that goes along with it, which is why you should talk to your FYE advisor or look at the actual policy if you have questions. We will admit in May if we have space available. We are constrained by our lab spaces. So we will admit as many as we can in May, all of the guarantee students, and then if we still have space in August and we have students who wish to come into BME, we will admit students in August. As of right now, we do not admit students in December, just because the fall semester sophomore year courses are prereqs to the spring sophomore year courses. We are currently working on creating a little bit more flexibility in our curriculum so that we can allow students to transition to major in December, but as of right now, it's just not possible. And then if you do have any questions, currently our student-led tours are suspended due to COVID, but we can still put you in contact with student ambassadors if you have specific questions. A lot of questions can be answered on our website, or you can also make an appointment to see myself or Corey through Boiler Connect. I can let you know I will be unavailable until probably mid-April due to registration, but Corey is available. You just have to select that T2M or Engineering Professional School inquiry as the reason to have his name pop up.
All right. And that's the end of our presentation. I'm going to stop sharing and have Andrew share the QR code that you're going to need to record your attendance for first year engineering, for Engineering 131. So Andrew, you can do that. And we are going to open it up to questions that you have. So you can either type in the chat and we will answer you, or you can unmute yourself and ask questions of me, Chantal, or any of our student ambassadors. And Andrew, do you have any advice if students have trouble logging into this QR code? Or
Yeah, so if you can't scan, just leave your name and Purdue email in the chat and I'll log your attendance. But I have been told if you have Snapchat, you should be able to scan this. And if you have an iPhone, you should be able to scan with your camera.
Yeah.